So, more limit definitions of the derivative. That's good. I can write down the definition of the derivative of f at some point x. So it will be f of x plus h, the value at x plus h minus the value at x, divided by the distance covered, which is x plus h minus x. In that case, x goes away and have h or h in the denominator. But this is a limiting process. And it's a limit as h gets very small, where h is this little displacement, little perturbation, where you examine the behavior of the function. By behavior, we mean rate of change or rate of growth or decay. Okay, then it's time to plug in some stuff. Okay, what is f of x plus h? It's x plus h squared plus x plus h. Okay, and what is f of x? F of x is just f of x, right? So I write this down in using a very big fraction. Maybe it doesn't need to be that big. Maybe I'm exaggerating myself. So this is f of x plus h. I'll color it in blue to make the connection. Minus, maybe I'll color this in green so you can also make the connection. But don't forget to put this in a bracket form, because the whole thing is being taken away or subtracted. Then this is being divided by h. Of course, this is all happening within the limit itself. We are taking the limit as h tends to 0. Now this is good. I think we have some choices here. Maybe I'll expand them just for us to see them. And then I'll minimize them again. So, yeah. So given this form of choices, I think we still need to expand this x plus h squared and then see what we get. So that is my suggestion for now. First, just quickly on the go, I want you to notice that we can cancel x with x. This is positive, and that is negative. So there's no problem with doing so. And then we get, if we expand the square, we get x squared plus 2xh plus h squared. Then we have 1h from here. And then we're taking away x squared, which is from there. Then we're dividing by h. A good question would be to ask if there are any like terms in this expression. And in fact, there is. You see them. Yes, it's x squared and x squared. So this is positive and this is negative, so they actually cancel out. And we are left with this expression, 2xh plus h squared plus h divided by h. Maybe I'll expand the choices once again to make sure we're not simplifying too much. So he wants it in terms of x squared. So maybe I will not simplify. So maybe I will not simplify this. I'll leave it as it is. Then I'll expand once again. And now let's see which expression is similar. Actually, looks like I oversimplified from the start. So I should not have cancelled this x and x. So I will add them and subtract them. I get just to stay consistent. So this is our x plus h. This is our square. And this is our f of x. And I think now we can compare and see which one is correct. I hope we can. Okay, this is not helping. Just look at them now as they are. X squared plus 2x plus h squared. Well, this does not contain 2xh in the numerator, so it's not it. Same thing here. So it's probably A or D. X squared plus 2xh plus h squared plus x plus h minus x squared minus x divided by h. So this seems to be the right answer. If we look at the final one also, this is just h. So actually it's not even A. I think it's because I'm having trouble with sight now. Looks. So this is x squared plus 2xh plus h. It's not h squared. It's missing an h squared. This one is not missing anything. So this is not the answer. And so I will cancel out. And you should choose the choice which is compatible with the definition, which is D. And now I can stop our suffering and bring this here and enlarge it as much as I can. Maybe, but not too large. That's not good either. So that is the definition of the derivative of x squared minus x. We might even go far enough and simplify it. I think we will get 2x plus 1 as the result. You can check this yourself. But otherwise, for this exercise, this is the correct formulation. You just have to compare and do not make the same mistake of oversimplifying. So it is good practice to look at the choices first and factor your steps in mind instead of just applying the algorithm, which is what I failed at following. Yeah, this is the exercise.